Okay, another situation. This is reinforced concrete. The column of a non-sway frame is shown in the figure. Given concrete FC prime, 28 megapascal. Given yung ating steel strength Fy, 415 megapascal. Tie diameter, 10 millimeters with clear cover of 40 mm. Consider bending parallel to line 1. This is the line 1, or that's the y-axis. And neglect the concrete area displaced by steel. Given yung dimension h1, you have h2, we have p1, and b sub 2. So, unang tanong, determine the geometric centroid. Pangalawa, determine the plastic centroid. By the way, from line 1 sila lahat, or from the y-axis. Part 3, determine the resulting moment if a load PU is 4155 kilonewtons acting 420 meters from line 1 along the x-axis. So, mga centroid. Unahin natin yung part 1. So, nilagay ko lang yung mga values natin ng dimensions. Okay. Geometric centroid. Pag geometric centroid yung hinanap, this is basically considering the concrete. Tatanggalin natin yung steel bars dito. Tanggalin muna natin yung steel bars. And then, makukuha natin yung centroid of a section by just using Varignon's theorem. Ang gagawin ko dito, i-cut natin yung ating section to two rectangles. Okay, una, itong shaded one. Tawagin ko yung area of concrete 1. Ito naman, area of concrete 2. Gagamitan natin ng Varignon's theorem. Gusto natin makuha yung location of the geometric centroid from line 1 or from the y-axis. Then we need the location of this corresponding centroid of the concrete from that y-axis. Tawagin ko siyang x sub 1. Ito naman, tawagin ko siyang x sub 2. Ito yung mga kailangan natin. So, for this figure, somewhere dito yung ating geometric centroid. Tawagin ko siyang x sub g. Ito yung hinahanap natin from the line 1. So, that is our geometric centroid. Again, Varignon's theorem yung concept natin, pero mas mabilis itong gawin sa calculator mode statistics. Then, i-on natin yung frequency. Sa x, yan yung location of the centroid of each of the section. Sa frequency naman, yung area of the section yung gagawin natin. Okay? Unahin natin to, section 1. So, x1. What is x1? So, if this is a rectangle, then x1 is kalahati ng 250. That's 250 over 2. Okay, what is the area? So, area of this section is 250. That is 250 times itong total dimension here. You have 300 plus dalawang 200. Again, that section is 250 times 300 plus dalawang 200. Itong total section here. That's the area. For section 2, etong x sub 2 dito, that is equal. So, that's coming from here. You have 250 plus kalahati ng 450. Nasa gitna yan. Plus kalahati ng 450. And the area of section 2, that is equal to 450 times 300. So, in this way, mas madali natin makuha yung ating location or the geometric centroid from the y-axis by using calculator. Yung x sub g is actually equal to the barred x. That's the arithmetic mean. That will give you 277.4 mm. That's the answer. Paano yan gawin? Paano yan gawin sa calculator? Alam muna natin si calculator. Okay. Palitan natin ang logo natin. Ito. Mode 3.1. On yung frequency. By the way, kung hindi nyo alam paano i-on yung frequency, shift mode, then button arrow down, then statistic, then on frequency. Ganun lang natin siya i-on. Then input lang natin. Una, you have 250 over 2. 250 divided by 2. Second is 250 plus 450 over 2. Pwede 0.5 of 450 na lang, no? Para hindi ka na pag-divide dyan. 1/2, kalahati or 0.5. Then the area, you have 250 multiplied by 300, then plus dalawang 200. 2 times 200. Then 450 by 300. 450 by 300. Okay, then press CA. Apps 5. Part X is our location of geometric centroid. Okay, ganun lang. Next. Dito naman, ano yung kaibahan ng ating plastic centroid and geometric centroid? Okay. Yung geometric centroid is the centroid of geometry. Kaya sa tinawag na geometric centroid. Centroid of the shape of the concrete. Of the shape. Centroid of the shape. Yung plastic centroid is the centroid of the forces acting on that, the capacity of the forces. Bale, each of these, itong concrete na yan, meron kang acting force here. That's stress times area. Itong concrete na to dito, meron ka ring acting force dyan. Force capacity that is stress times area din. Ngayon, we need to consider the steel na. I-separate ko lang yung steel dito. Kasi yung steel, meron din yung force na i-contribute. And mas malaki yung force dyan, no? For steel. Contribution. Okay? So, sinaparate ko yung ating steel. So, mode stat pa rin. Again, dito I have line 5 na. Unahin ko to. Meron kang force provided by the concrete. Itong first section natin. What is force? XC muna. Ano yung location niya? Same pa rin kanina. X1 is 250 over 2. Ano yung force dito? Stress times area. So, stress capacity for a concrete is 0.85 FC prime. Yung area niya is 250 and ito, the same kanina. 250 times 300 plus dalawang 200. That's the total dimension here. So, this becomes a force kasi i-multiplyan natin ng stress. Okay. For this one naman, yung x sub 2, still yung x sub 2 natin, the same lang din kanina. 250 plus kalahati ng 450. So, yung nagbago, meron ka ng 0.85 FC prime. That's the stress. The area is 450 by 300. 450 by 300. Ayun, take note. Mag-contribute na yung ating steels dito for the forces. Alright, unahin ko ito. Itong line of this steel. Ganun pa rin, stress times area. Tawagin ko yung location niya as x sub 3 from line 1. X sub 3. What is x sub 3? So, by the way, we need the clear cover. Meron yan binigay sa problem. Clear cover. This one. Clear cover of 40 mm. And by the way, the diameter of the tie is 10 millimeters. The tie diameter. Ito yan. 10 mm. Lahat ng ties dyan are 10 mm. So, what is x sub 3? Paano kunin yung x sub 3? So, x sub 3 is equal to the clear cover plus isang tie diameter. Merong ties dyan. plus kalahati ng bar. Take note, 25 mm bar yung ginamit. Kalahati ng bar. 25 over 2. Again, ito yan ha. 40 plus itong tie na yan plus kalahati ng bar. To the centroid tayo, of course. Now, ano yung force na kinontribute ng apat na area na yan? So, area times stress tayo. The area of these 4 bars is pi over 4 times 25 squared. Then, 4 times 4. Then, yung stress natin is the Fy for steel. By the way, Fy yung gagamitin natin dito. Kasi sinabi niya sa problem na neglect the concrete area displaced by steel. Hindi natin i-consider. Kasi as you can see, pag mayroong mga bars dyan, mayroong nawalang concrete dyan. So, we will neglect yung nawala. Kung i-consider naman natin, maliit lang yung difference niya. We will try that one later. Papakita ko siya sa mathcad. Yung difference lang. Okay, so ito pa lang yan, yung unang line ng steel from line 1. Ito naman, ito of course mag-contribute din yan sa force. Tawagin ko siyang x sub 4 yung location from line 1. So, kailangan ulit natin yung x na yan. Ang gagawin ko, yung x sub 4, that is 250. Then, atras tayo ng 40 mm. Kasi dapat to the centroid ng bar na ito. Minus 40 mm. Then, atras pa tayo ng tie diameter. Minus 10. Then, to the center tayo ng bar. Minus 25 over 2. Again, ito yan ha. 250 ito. Minus 40 minus 10. Minus kalahati ng diameter. 25 para nasa gitna tayo. And ganoon pa rin yung area ng dalawang bars. Pi over 4 times 25 squared times 2. Dalawang bar. And yung stress natin is Fy. And yung last is itong 4 na bar sa pinakadulo. We need to locate that one. Okay, to the centroid pa rin. Tawagin natin siyang x sub 5. So, what is x sub 5? So, maganda kunin natin to. Itong lahat. That's 250 plus 450. 250 plus 450. Then, atras tayo ng 40 clear cover. Atras tayo ng isang diameter ng tie. 10 mm. And dapat sa center tayo, sa centroid ng bar. Atras pa tayo ng 25 over 2. And yung area ng 4 na bar, 25 mm pa rin yan. You have pi over 4 times 25 squared times 4 times Fy. So, Fy and Fc prime and Fy are givens dito sa problem. Okay? Ito yung ating Fy, Fc prime, and Fy. So, yung ating location, tinawag ko siyang x sub p for plastic centroid, still the bar x. That is 286.1. The answer here is letter A. 286.1. Alright, gawin natin siya sa calcu. So, yung gagawin ko para hindi tayo paulit-ulit mag-input ng Fc prime, Fy, no? Kasi paulit-ulit yan. Gagawin ko dito, I will store that one sa calculator muna para hindi tayo dragging, no? 28 yung ating Fc prime. Pwede 0.85 Fc prime yung input ko dito. 0.85 Fc prime. Fc prime is 28. I will store this one sa, let's say, C for Fc prime. Then, Fy naman, i-store ko siya sa Y. Dito. Yan, store ko siya sa Y. And itong area ng bars, ito, is area ng isang bar, i-store ko yan sa A. Para hindi tayo paulit-ulit mag-type. Pi over 4, that's 0.25 pi times 25 squared. This is area of one bar only. I will store that one to A. In this way, hindi tayo paulit-ulit dito mag-type ng mga values na yan. Then, mode 3. Mode 3, 1. Again, on yung frequency. So, una, 250 over 2 times 0.5. 250 over 2. Then, you have 250. Okay, yung second row. That's 250 plus kalahati ng 450. Next is 40 plus 10 plus kalahati ng 25 mm. Okay. Row 4, 250 minus 40 minus 10 minus kalahati ng 25 mm. Last one, 250 plus 450 minus 40 minus 10 minus kalahati ng 25 mm. And for the frequency, yung area. So, 0.85 FC prime, ito, na-store natin yan sa C, ha? So, that's lang ako. Recall C. Ayan yung ating 0.85 FC prime. Then, multiply natin ng area. So, times 300 at 250. That's 250. Times 300 plus dalawang 200. Then, second one, again, yung 0.85 FC prime nasa C yan. So, I have recall C times 450 times 300. Alright, row 3. Etong area na yan, area ng 1 bar nasa A. Recall A times 4 times Fy. Yung Fy naman natin nasa Y. Mas mabilis. Okay. So, dito, that's on A. Recall A times 2 times Fy. Alright, fifth row. Nasa A yan. Alright. You have A times 4 times Fy. Yan. Then press AC. I mean CA. Then barred X ulit. Nasa apps 5 barred X. I hope wala tayong maling nagawa. Tama. 286.1 mm. So, napakadali, no? Using the mode 3 to mode statistics sa calculator. Kung mano-mano yan, Varinion theorem yung concept natin. Meron pang pangatlong tanong dito. So, nakuha na natin yung location ng plastic centroid. Ito talaga yung gagamitin natin for design. Location of the plastic centroid. Tabi ko siya dito, ha? So, that's the plastic centroid location from line 1. Determine the resulting moment kilonewton meter if a load PU acting 4155, PU 4155 kilonewton acting 420 millimeters from line 1 along the x-axis. Ano daw yung ating moment, resulting moment about the neutral axis? Bale, itong ating location of the plastic centroid is the neutral axis of the section in terms of force. So, yung PU daw, nag-act, that one, will be acting 420 from line 1. From line 1. Ito yung line 1 natin. Along the x-axis. Ayan. Along the x-axis from line 1. Ano daw yung moment na makukos natin? Yung moment dyan is the moment about the neutral axis. So, meron kang eccentricity about this plastic centroid. Tawagin natin siyang E. So, paano yan? Alright. So, tingnan natin siya in 3D. Meron ka daw force PU applied at that point. Yan. Okay. So, kung meron kang PU dyan, ito yung ating neutral axis. Then, it will cause moment about that neutral axis caused by the eccentric loading. This is now eccentric. Wala siya sa gitna. So, ang gagawin dito, we can transfer that one to the centroid, to the plastic centroid. But we need to account the moment. Meron ka ng moment about that neutral axis. And again, that moment, which is our mu, is P, if P is here, times the eccentricity. So mu is equal to that P given, Pu, times the eccentricity. So Pu is 4155 kilonewton. Yung eccentricity E is the difference of this. 420 mm minus 286.1 mm. Gawin ko siyang in terms of meters. 0.42 minus 0.2861 meters. So the answer here is 556.4 kilonewton meter. And that's it for this equation.